Welcome to another video. In this section, we want to talk about the calculations on the Lussac'S law of combining volumes. So this calculation illustrates the Lussac'S law of combining volumes. So before I solve this question, we need to know what the Lussac'S law of combining volume, what it is. The Lussac'S law of combining volumes states that when gases react, they do so in volumes which bear simple ratio to one another and to the volume of their product if gaseous, provided the temperature and pressure remains constant. Now let me write it on the board for clarity, because so that whenever we are solving the question, we are going to make reference to that law to define some rules. So now let me state it on the board. The Lussac'S law of combining volumes. The Lussac'S law of combining volumes. So let me write the Lussac'S law of combining volumes states that when gases react, they do so in volumes which bear simple ratio to one another and to the volume of their product if gaseous, provided the temperature and pressure remain constant, provided the temperature and pressure remain constant. So that is the Lussac'S law of combining volumes. When gases react, they do so in volumes which are in simple ratio or which bear simple ratio to one another and to the volume of their product if gaseous, provided the temperature and pressure remains constant. Now in the context, we were told that 20 cm cube of hydrogen were mixed with 100 cm cube of air. Let's first treat those two lines. The first two lines, let's interpret it. 20 cm cube of hydrogen were mixed with 100 cm cube of air containing 21% by volume of oxygen. Now, the volume of air, 100 cm cube of air contain 21% of oxygen and 79% of nitrogen and other noble gases, of nitrogen and other gases. Now what we are going to do here is that the one that is useful in the calculation is that of oxygen. So others will be treated as residual. So how do we go about that? We are going to find 21% of 100 cm cube. So percentage, that is the volume. Let me write volume of oxygen is equal to the percentage, that is 21%, 21 over 100 times the volume of air is 100 cm cube. So we can find the volume of oxygen in that regard. So that is 21 cm cube of oxygen. So what we are going to do now to get the volume of other gases, nitrogen, carbon dioxide, noble gases, and all of that. So we have 100 minus 21 cm cube. So that is 79 cm cube. That is the other gases. Other gases. So nitrogen takes the integral part of that. Is why we said nitrogen. Collectively write it as nitrogen. So this 79 cm cube will be treated as residual. That means after our calculation, we are going to add 79 cm cube to the residual we got in our equation. Now the first thing we are going to do here is to write the chemistry of reaction. To write the chemistry of reaction for the question. 20 cm cube of hydrogen were mixed and sparked with containing 21% by volume of oxygen and exploded. At times they use spark, they use exploded. So what was the composition and the volume of the residual gas if all the measurements were taken at STP? STP means standard temperature and pressure. So now the first thing we are going to do here is not far-fetched. So we are going to write the chemistry of reaction. Chemistry of reaction. So on the next column, we are going to write the combining volumes. That is the next line. Then the next line is going to be volume before sparking. Before sparking. Then the next line is volume after sparking. Then the last line will be the volume of residual. Some use residual, some use resulting. Residual gases. So now let's pick them one after the other. Then the chemistry of reaction is the first thing whenever you are dealing with questions on Lussac'S law. So we're told that hydrogen combined with oxygen. So and the volume of oxygen is known. So hydrogen, the ratio in which hydrogen combined with oxygen is H2 plus O2 will give 2H2O. So let's check whether the equation is balanced. It's not yet balanced, so we include 2 here. 2 times 2, that is what? 4. 2 times 2, that is 4. 4 hydrogen. The hydrogen is balanced. Then oxygen. We have 2 oxygen on the reactant part, then 2 oxygen on the product part. Then the combining volumes is the next line. The combining volume here, we can see that we are having 2 moles of hydrogen and 1 mole of oxygen, giving rise to 2 moles of water. So this is the gaseous state, this is the gaseous state, this is the liquid state. We need to include that. So the combining volume is the next thing we are going to write. So now we are having 2 volumes of hydrogen combining with 1 volume of oxygen to give 2 volumes of water. Why am I writing volume? What I was having from onset was mole, 2 moles of hydrogen gas, 1 mole of oxygen gas. But if you remember vividly, there was a law in gas law, which is also called Avogadro's law. Avogadro's law states that equal volume of all gases at the same temperature and pressure contains the same number of molecules. Equal volume of all gases at the same temperature and pressure contain the same number of molecules. What does that mean? It implies that I can change mole, I can change it to volume due to Avogadro's law. So that is the meaning of what I do. So that means I'm transforming number of moles to volume. So it's still the same. Then combine a volume before sparking. Now let's go back to the context. 20 cm cube of hydrogen. That is the volume of hydrogen before sparking. So I'm going to write 20 cm cube. Then mix with 100 cm cube of air containing 21% by volume of oxygen. So that means before sparking, we've done that here. percentage of oxygen is 21, then the volume of oxygen will definitely be 21 from our calculation. So the volume of oxygen before sparking is 21 cm cube. Then before sparking, this is dash, there is nothing there. Then the next stage is the volume after sparking. How do we get the volume after sparking? You look for the combining ratio, combining volumes, 2 volumes of this combining with 1 volume of this. That means whatever we get here, half of it is what will be on the oxygen part. Because 2 volumes, this is 2:1. When you put it in terms of ratio, it is 2:1 mathematically. So that means if I'm having, let's say for instance, if I'm having 10 here, what will be here will be 5. If I'm having 20 here, what will be here will be 10. So that's the illustration. So because 2:1, 2 volumes here, 1 volume here. So that means the volume after sparking, I will rewrite 20 as it is. That is the volume after sparking because this is 2 volumes. I will now I will take half of that 20 because this is 2:1. Half of 20 will be the volume of oxygen after sparking. So half of 20 is 10 cm cube. Then if I'm having 2 volumes here, I will also write 20 cm cube here for water. But at the end of the day, we are going to leave water behind. We are going to leave water behind. Why are we going to leave water behind? Because Lussac'S law states that this statement, let's underline this statement. Their simple ratio to one another and to the volume of their product if gaseous. Underline that statement, underline. That means anything we are treating here must be gas. Anything that is not gas will be left out of the calculation at the end of the day. So that is the reason at the end of the day, water will be left aside. The only time we deal with water as gas is if in the context we were told that at 100 degrees Celsius, so at 100 degrees Celsius, water becomes vapor. It's no longer liquid, so we are going to treat it as gas in that case. But this case, it is at standard temperature and pressure. On the normal temperature and pressure, water is liquid. So that is the reason at the end of the day, this will be left out of the calculation. So we've gotten the volume before sparking. Residual gas. How do we get the volume of the residual gas? We are going to subtract the volume after sparking from the volume before sparking. So let's do the calculation. 20 cm cube minus 20 cm cube, 0 cm cube. 21 cm cube minus 10 cm cube, 11 cm cube. Then this one, just write 20. So, but this one will be ignored due to the fact that it's not a gas because from the condition says if gaseous. So this left out of the calculation. So the volume, the question goes in 2 ways. The question says what was the composition and the volume of the residual gases. So you now have to answer the question in 2 ways. The composition of the residual gases is 11 cm cube of oxygen and 79 cm cube of nitrogen and other gases. Due to the fact that in our first calculation we extracted oxygen out. So since we extract oxygen out, then the remaining I said it will be treated as residual. So this one, they are also residual. So the composition of the residual gases is 11 cm cube of oxygen and 79 cm cube of nitrogen and other gases. That answers the first part because the question requested for composition and volume. So how do we get the volume of other gases? We are going to add the volume of the oxygen residual and the volume of other gases residual. So hence, the volume of the residual gases is, that is 11 cm cube plus 79 cm cube. So the numerical effect of this, what is the numerical effect? 1 plus 9, 10, keep 1, 1 plus 7, 8 plus 1, that's 90 cm cube. So the computation of this is 90 cm cube. So hence the volume of the residual gases is 90 cm cube. So So that comes to the end of today's section. So don't forget to like and subscribe to my channel. So attribute calculus. So life is continuous, life is differentiable, life is integrable, but not the best measure.